In section 2 of chapter 2, it's just more of the same. Instead of doing one transformation at a time, we're doing multiple transformations at a time. Now, the very first lesson, I wanted you to come up with your own vocabulary because I wanted you to internalize how you understand it, and all you did fantastic. This lesson is largely designed for me to teach you the vocabulary we will use that is more proper in a mathematical setting. All right, first, I want to go through a couple examples of each type of transformation. The first one, I have y equals the absolute value of x minus 3. What you would get is this graph right here. Here's where your vertex would be, and then it would go up one, right one, up one, right one, up one, right one. And additionally, it would go up one, left one, up one, left one, up one, left one, up one, left one, up one, left one. And I would describe that as, hey, that looks like the mother function if I just moved it to the right 3 units. So that's my description, right 3. Now, there are other ways you could describe it, involving things like phase shifts and whatnot, but we're just going to stick with right 3 because it tells us the direction, tells us how much, everything we need. The next one, I have the absolute value of x plus 4. Surprise, surprise. It's just going to be shifted left 4. And that's how I am going to describe it. Third, now we're dealing with addition and subtraction that's on the outside of the operation, that's on the outside of the absolute value sign. So now I have a plus 5. Now if it was on the inside, it kind of does the opposite. A negative makes us move right, a positive makes us move left. When it's on the outside, it does exactly what you'd think it'd do. A positive is going to make us go up 5. And then that minus, the negative, is going to make me go down to 8. And so this is what it's going to look like with linear transformations. Up 5, down 8. Now let's go over slightly more complex transformations. What happens when we deal with multiplication? Now, some of you were using the term slope. That's fine in that first concept. The problem with us saying the slope, because if I did number 1, yeah, it has a slope of 2, kinda, but there's a problem with utilizing that vocabulary. It only has a slope of 2 on the right side of the vertex. On the left side, it would have a slope of negative 2. So slope is not an adequate descriptor of what is actually going on. We have to use a different vocabulary term. And the one that we use is that it is stretched vertically by 2. Imagine this was just like a JPEG, like you had a picture of the mother function and you just made it 2 times taller. That's what this red graph would look like. You're stretching it vertically by 2. You can't just say stretched by 2 because we can stretch a picture in a variety of ways. You can stretch it vertically, horizontally, diagonally. You have to give a directional description along with the fact that it's being stretched. Now I'm actually going to change the second problem. I'm going to make it a 1/3, a negative 1/3. Actually, let's make it a 1/3. I won't deal with negatives till later, till the next one. Now if I graph that one, it still hits the origin because I'm not going left, I'm not going right, I'm not going up, I'm not going down. But this one, we're going to go up 1, right 3. And we're also going to go up 1 and left 3. Same thing. This looks like the mother function, except I'm not making it taller. I'm not stretching it. I'm compressing it vertically. And those are the words that we use for this. Compressed. Vertically, which I'll abbreviate as vert. By 1/3. Now, how do we recognize if it's stretched or compressed by just looking at the equation? If the number in front is bigger than 1, you're stretching it. If it is smaller than 1, if you plug this into a calculator and press enter, and it produces a decimal with the first term being a 0, then we are compressing it. We do not care about the negative. The negative will do something else. So bigger than 1, we're stretching. Smaller than 1, we're compressing. If it's equal to 1, you won't add a description to this because it's not stretching or compressing. Green one, I have a negative 4 over 5. Well, the 4 over 5 tells me, because 4 over 5 is smaller than 1, that I'm going to be compressing it vertically by 4 over 5. Not negative 4 over 5, just 4 over 5. The negative is going to do something different. The negative tells me that when I graph this, going to the right, it's going to go down 1, 2, 3, 4, and right 1, 2, 3, 4, 5. 1, 2, 3. And the thing that makes the green one different than the rest is it's upside down. Except we don't use that term. We say it's flipped. And we have to give a direction, because you can flip a function in a variety of ways. I can flip it vertically. I can flip it horizontally. I can flip it diagonally. So we have to say flipped vertically. Some textbooks say it's a reflection across the x-axis. The reason I'm not a big fan of that is because then you have to worry about the order you use your vertical description, because you're supposed to do the flip first. And a lot of people describe the left and right motion first, and you're not supposed to do that if you're doing a reflection. And that all sets us up for the purple one. The purple one is all of this thrown together. I have a +2 inside of the absolute value signs. That means left 2. I have a -3 on the outside of the absolute value signs. That tells me down 3. I have a 6 over 7 being multiplied. 6 over 7 is smaller than 1, so it is compressed vertically by 6/7. And then that negative tells me it's going to be flipped vertically. None of these words are just superfluous. You can leave them out of your description. You have to use all of those words I have written. You have to tell me direction for left or right. You have to tell me how much. You have to tell me direction up or down. You have to tell me how much. You have to tell me if it's stretched or compressed. You have to tell me that it's vertically, and you have to tell me by how much. You have to say if it's flipped, and you have to tell me which direction. None of those words are just haphazardly thrown in there. You have to use all of those words. So, time to graph. Left 2, down 3. 1, 2, 1, 2, 3. There's my vertex. And then it's going to go down 1, 2, 3, 4, 5, 6. And then right 1, 2, 3, 4, 5, 6, 7. Left 1, 2, 3, 4, 5, 6, 7. Here's my graph. And we are done.